Okay, I think we will go ahead and get started. So good afternoon, everybody. Thank you for joining us today. My name is Jen, and I'm going to be moderating the webinar today. Before we get into the presentation, I'm going to quickly go over a couple of housekeeping items. Right now, I do have everyone on mute just to avoid background noises that may distract you from listening to the webinar, but we do want to encourage active participation. So if you have a question, please type it into the question box at the bottom right-hand side of your webinar screen. I will be monitoring the questions as they come in, and we will answer as many of them as possible at the end of the webinar. So with that, I want to introduce our speaker today, Patrick Vinton. Patrick is our CTO at Analytics 8, and he has over 20 years of experience in all aspects of BI and data and analytics rollouts. He has worked in over 100 BI environments in every major industry and has co-authored 4 patents related to BI report development, SQL generation engines, and BI application server scalability. So with that, I'm going to turn the presentation over to Patrick, and we'll get started.
Hey, thanks, Jen, and thanks everybody for joining today. So today we're going to take a I'd like to call this like a primer of the cloud and cloud computing. We're going to just kind of briefly go over some definitions, some reasons why to go or why not to go to the cloud, and we're going to talk about some other considerations here. A couple things that I want to point out here. If you're expecting a technical deep dive, this isn't going to be the webinar for you. The goal for today is to establish a baseline understanding of cloud, so we can have more intelligent conversations about it later. And that was kind of a good reason why we had this webinar in the first place. So a lot of the work that we've been doing over the past few years at Analytics 8 is helping customers modernize their server architectures and their data architectures. And what we found is in having conversations with them, often the first part of the conversations we were taking was to educate people on some basic terminology. So that was what prompted the webinar today, is to kind of get a baseline understanding for everybody out there. So with that said, we're going to start off with some definitions. And I should also point out that for a lot of these definitions, depending on who you talk to, they may have a different definition than I do. There's a lot of varying definitions for most things that we talk about here. Another kind of disclaimer is some of the things I say today may not be 100% technically accurate, but they're definitely good enough to have a high-level conversation. So I keep that in mind for those of you who are cloud experts who may be picking some of my words apart in there. And some of these we're taking a little bit of liberties to help some of the newbies have a baseline understanding. So what is the cloud? The cloud, in my definition, it's hosted server resources that are leased. And server resources basically fall into 2 categories, into compute and storage. And at the compute, basically what we're talking about there is we're talking about processors and RAM or memory. And storage, we're typically talking about disk space. Now, a lot of people will take these up a higher level. Like for example, on compute, you could have like certain types of processing as a service, or you could have basically machine learning as a service, or various things as a service on top of the compute. But at a kind of at a core level, these are the 2 categories that server resources in the cloud are broken down into. So I've already mentioned this a couple times, and a lot of these things I'm going to repeat over and over because they're all related and it doesn't hurt to hear them multiple times. But I've already mentioned the term as a service. And I want to point out, for a lot of people that first hear this, they think it's just a marketing term, and it's really not. When you purchase something as a service, you don't own it. And so an example that I like to provide for this is when you talk about getting a haircut. Now, a haircut that's a service that you pay for. Once you've done paying for a haircut, you don't own a haircut. You just had that service performed on you. So that's an example of something that you buy as a service. Something else, what you'll often see in when we talk about cloud computing, is sometimes these providers will charge it by consumption. An example I like to give there is when you think about electricity delivery to your house. So you don't own the electrical grids, you don't own the transformers, you don't own all that stuff. I mean, I guess you own the copper that's inside your walls and the wall outlets. But really what you're paying the annual bill to the power company is your consumption of the electricity. And the more you use, the more you pay. The less you use, the less you pay. Now, not all cloud resources are charged that way, but that's what a lot of people are doing, and that really is the kind of the movement of the future. And I think that's what we're going to see more and more of the cloud providers do is charge by consumption. And when we talk about cloud computing, there's lots of other things, and this is where things do start getting a little bit marketing-ish, but more or less they fall into three categories: software as a service, infrastructure as a service, and platform as a service. Let's start with the easy one first, software as a service. You know, the biggest household name here by a long shot would be Salesforce.com. And so in the case of Salesforce, there's nothing to install on your computers. You just log into their website, and magically you have a CRM software at your fingertips. It follows you around wherever you are. There may be a bunch of servers, there may be a bunch of upgrades, there may be all kinds of stuff behind the scenes. You don't know or care. All you know is it's available to you over the web. And for the other two ones, I think it's good to go ahead and go to this next slide. I just found this just a few hours ago, actually, that compares these three as a services. This is not a grid that I made. This is one that BMC made. There's the link at the bottom if you want to go see the full article yourself. But this kind of illustrates what I was talking about when I was talking about Salesforce. There's a whole lot going on behind the scenes, but you don't really know or care about that. All that stuff is being managed for you. But, you know, here, not all of our companies is going to run off CRM. You know, there's several other operations our company needs to survive. And so that's when we need platform as a service or infrastructure as a service when we start talking about cloud computing. And you can see the subtle differences there. The key thing I want to take away from this slide is, you know, when we look across the spectrum, sometimes the cloud service provider does everything for us, and sometimes we are responsible for it, and sometimes, although it's not illustrated very well in this slide, we have a shared responsibility. Specifically, when we talk about security, security isn't really articulated very well in this slide, but that's a good example of where we have a shared responsibility in many of the cases. So let's now talk about what a typical on-premise server architecture looks like. You know, we've got a bunch of physical boxes or virtual machines that are somewhere. And typically, those are like locked away in a server room. And before we start contrasting that to the cloud, let's talk about what else we are dealing with when we talk about on-premise servers. So we're talking about the electricity to run those servers, and that's a significant cost. And if anything that's powered by electricity, we need a battery backup. So those things aren't cheap. And those servers run hot. They need to be kept cold. Often these server rooms have dedicated air conditioning systems. And obviously there's the costs of the air conditioning system, but also the cost of electricity to run the air conditioning system. And then there's also the cost of the real estate footprint that is. You know, that actually is room that could be used for an office, for something else that you're actually paying, you know, real estate for. And then there's also the physical security to keep people out of that server room. So there's a lot more going on than just a bunch of servers and, you know, blades in a rack. There's a whole lot more going on. So let's keep that in mind when we start talking about costs later, because that's some things that people often forget is when we're talking about resources, it's not just compute and storage that we're saving money on or we're shifting the money around on. We're actually talking about potentially saving money on all the things that we're showing here. Okay, let's tidy this up back again. Let's talk about a transition to the cloud. So in this case, we've done a couple things. We've moved some of our servers out of our firewall. And really, we're not actually moving them. This is a case where we'd be leasing them from a cloud service provider like Amazon or Azure or Google Cloud or some other ones out there. Those are the three big guys out there. And so in some cases, we move the entire servers across, and we kind of interact with them as a server unit, kind of like we have done for years and years and years. But the other thing you may notice here is that sometimes we can move just discrete processing and discrete storage. We can separate those resources. And so an example that some of you may be familiar with, if you've heard about it, Amazon S3, you know, their storage. That's something where you're not paying for processor or for RAM, you're just paying for the storage. So that's an example of that. So now we've got a simple baseline understanding. Let's talk about public versus private. And let's go back to that last slide we just looked at. And actually what we just looked at is what we were interacting with there was the public cloud. And again, we're gonna go into details on this in here just a little bit. But basically in a public cloud is these cloud resources are separate from your internal resources here on the left. And you have to traverse your firewall to get to them. Now, again, there's more differences that I'll clarify here in a moment, but that's the kind of the biggie when we start looking at pictures and architecture diagrams. And so when we start talking about a private cloud, and again, when we're just talking about pretty pictures and diagrams, really all we're doing is sliding in all of those cloud resources behind our firewall or pushing our firewall out to accept some of these cloud resources. So what are some of the other differences? So when we talk about resources that are in the public cloud, most of the time when we talk about that, we are actually sharing resources with other people on there. Now that's transparent to us, and all these cloud providers, they stake their futures on keeping everything secure and nobody has access to anything. But the reality is behind the scene is they've got gigantic servers out there, and they're logically slicing them up for us to share. So when our data and our processing are side by side with other people's. Consequently, that means it's relatively cheap, at least especially when we compare to a private. It also means it's very fast to provision. We don't have to do anything on our network to let it in. We just basically click a few things in our mouse, and there we have access. And that means not only it's fastest for our admins to provision, it's also fastest for our end users to gain access. Anybody who has access to the internet can have access to this cloud resource. And the good thing about the public cloud system is because they are the ones that were responsible for slicing up the server resources, that also means they're the ones that are responsible, or mostly responsible, for security and maintenance, including server upgrades and patches and things like that. And again, remember my disclaimer, what I'm saying here isn't always 100% true, but this gets you pretty close, especially to get a baseline understanding. So if we contrast that to a private cloud, in a private cloud, when we get our resources, those are ours and ours only. Those are completely insulated from other users that are out there using cloud resources. Consequently, that means those server resources that we are leasing, they're more expensive. And the other thing to consider is it's not just the server resources that are more expensive, it's actually more expensive for us to use. And the reason is because if we remember on the prior slide, those things are inside of our network. And that means that we share most of the burden for keeping security up to snuff and maintaining those servers. So there are some definite pros and cons for the two of those. So a lot of people say, they make the assumption, well, if it's private, it's going to be more secure. Well, that may be true in some cases, but the reality is, unless you are really good at server maintenance, and the public can be as secure, if not more secure, than private. So that we're going to talk a little bit more about that later. But that's a big misconception out there that private is always more secure than public. So why should we or should we not go to the cloud? Well, I just kind of touched on this. Other companies do server maintenance better. And the reality is, if you are Amazon or Microsoft or Google, you've got hundreds, if not thousands, of employees, and their only job is to maintain servers. They're doing nothing but making sure everything is patched. These are the world's best security engineers. They do a bunch of scalability testing, white hat security testing. They do it better. They simply have more resources to do this than we can. But especially in the case of private cloud, that doesn't mean that we can just throw up our hands and say, we're done here. We have no responsibility. Because if we think back a couple slides ago at that grid, when we were talking about platform as a service and infrastructure as a service, we still have a lot of responsibility on there. And especially when it comes to private, we have a lot of responsibility for security. Most of the time, but definitely not all the time, we're going to have cost savings. So the costs of the servers that we own over time often is more expensive than if we were to lease the resources. But remember, there's other things in play there. Some things that are in favor of cloud is that we don't have to pay for things like electricity or air conditioning or real estate to host these things. But what that also means is there are some things that drag down and kind of argue against cloud. And remember, that means we still have to have security, and we still have to be careful that we're not have runaway resources there in the cloud. Another one, it matters mostly to our accountants, but that's operational expenses versus capital expenditures. I'm not going to go into a whole lot of detail on that, but a capital expenditure is an accounting term for it's something that you own and it depreciates over time. And in some cases, people's finance departments or accountants, that's where they want to put their computing resources. The opposite of that is going to be an operating expense, and that's something that you just need to exist as a company. You know, electricity would be one. You know, payroll, basic utilities. When you're talking about cloud services, that goes in the same category as some of these basic utilities. And so, depending on what a company's situation is, one or the other may be preferred. So we talked about, several times now, the cloud service provider bears much, if not all, of the responsibility for making things secure. But that doesn't mean that we don't ever have to think about security again. It just means we have to think about security in different ways. We have to think about things like authentication. If it's a private cloud, we need to handle our firewalls differently. Maybe we've had physical firewalls for 2 decades, and now we have to deal with a software firewall that's virtualized in the cloud. So it's a different kind of security, but it's typically something, unless we're talking about a pure software as a service, it's something that we still have to consider. Typically, the ease of rolling out a cloud application, assuming you already have a cloud provider relationship and some stuff set up, the ease of rolling out a new application is much easier when you're doing this in the cloud. And kind of dovetailing into that would be if you want to quickly prototype something and see if it's going to work. It's real easy to click a few clicks on your mouse, provision a server, start doing some prototyping or some development, and if it works, great. Then you can grow that server and make it something permanent. And if not, all you have to do is click a mouse click and that server's gone forever. So that's why a lot of companies love to do prototyping in a cloud-based sandbox. Another consideration that we see with our customers who are global is putting some of the server resources close to their end users. So for example, we have a customer that's got several offices throughout the US as well as South America and Asia. And historically, all the servers had been in the US. And all of the American users, they had great performance. But unfortunately, the South American and Asian users suffered some pretty bad performance. And it was for a very simple reason why. They were trying to interact with server resources across the ocean and across a very long distance and traversing many different parts of the internet to get there. So what we were able to work with them to do was help move some of these server resources closer to the end users themselves, and that satisfied some of their performances because we actually were able to move some of the resources closer to them geographically. And one of the last reasons why we would want to consider a move to the cloud is tighter integration with cloud resources and other things that are offered. And so there's a really good chance, for example, you're already using something in the cloud, and you probably have a lot of data already up in the cloud. And so if you can move some of your compute resources closer to that data, you don't have to overcome that inertia that data has, and you don't have to bring it on premise. You can go cloud to cloud. Also, and when you start talking about the big three, the Amazon, Azure, and GCP, the Google Cloud, they have more than just RAM and processing and storage. They have machine learning, they have voice recognition, they have all these different services. If you go to the AWS webpage, for example, they've got a whole page of services there. So if we are already putting some stuff up there, it's very, very easy to take advantage of these other resources and features that these cloud service providers offer. So migration considerations. So it's kind of sometimes a letdown for people to see this slide because, this could look like almost any other IT project slide. And, as different it is, it's the same as most other IT projects in many ways. And then first and foremost, we have to know and state our goals. What are we trying to do with a move to the cloud? Are we trying to save money? Are we trying to avoid maintenance contracts? Are we trying to get closer to our data? Are there features that we're trying to do? Are we trying to have more rapid prototyping? These are just some of many reasons why you'd want to do it. But before you do anything, you've got to understand why. And that's going to dictate almost everything else on this page here. And once you know your goals, what are your budget? And does this budget actually make sense for your goal? If I solve this problem, is that going to be worth more or less than I have budgeted? Also, with almost any IT project, assessment of current state. What do we already have on-prem? What do we already have in the cloud? What needs to be moved? And then in the process of this is going to affect some business operations or departments. You need to identify those folks. We said this 100 times already, but we need to consider security. And most of the times when people think about cloud security, they think about hackers coming in and trying to get access to a database and pull data down. And that's obviously a very important thing. Luckily, the cloud service providers protect us from most of that stuff. But the one thing that we've seen that our customers often forget about, at least until we guide them the right way, is authentication. So great, now we've got all these resources and data in the cloud. How are our end users going to authenticate and be able to use them? So, I mean, if you want to be kind of quick and dirty about it, you can have a separate authentication, a separate name and password for these cloud resources. But maybe you want to do something a little more sophisticated. You want to use an identity provider that you already have and use SAML or some sort of single sign-on so it's a seamless experience for your end users. So this is something that often people neglect to think about up front when they start thinking about migrating to the cloud. Another biggie, and this is kind of catches people off guard too, if you're talking about moving data centers to the cloud, whether it's relational or especially non-relational or unstructured data, the sheer time it's going to take to move all that data to the cloud. You can't move 100 terabytes into 5 minutes. Sometimes when we help customers scope their cloud migrations, they're often surprised that, oh my gosh, this is going to take 2 weeks just to migrate the data. Once we hit go, it's going to take that long just to move all the data up to the cloud. So that's something when you start planning and mapping out impacts, you need to make sure you estimate the time that it's going to take to physically move that data. And I've said this a couple times, plan. See what the impacts are. Need to break out the old Gantt chart to see, what needs to be done in what order and what are the impacts going to be. Again, just like any other IT project. So with that, so I've seen a couple questions come in, and that's a perfect segue because I think that's actually all the content I've got. Yeah. We had a question is, what percentage of our clients are using cloud for their implementations? Kind of closely related to that, is this number changing? And let's see if I can answer 3 questions at once here. What percentage of our clients are using cloud for implementations? Well, it depends on how you define implementations. I would guess 99 to 100% are using the cloud in some capacity for something. Maybe it's a time tracker system, or maybe it's Salesforce.com. I'm guessing, since looking at this audience, I guess we're talking about our business intelligence or our analytics implementations. If we're talking about the latter, how many people are using the cloud for their analytics implementations? I'd say that's pretty close to 50%. And within that number, I would say it's pretty close to 50% Amazon and 50% Microsoft Azure. No real patterns that we can see between the two. It just seems that some companies had a prior relationship with Amazon and some had a prior relationship with Microsoft. And is the number changing? Yeah, we are absolutely seeing that growing day by day. This is becoming one of the biggest parts of our business, helping customers modernize their server architectures, and more importantly, their data architectures. What do you think is the biggest driving factor? One of the biggest driving factors that I see is the ability to move quickly. Now, we talked about just a few minutes ago that there are some things that take a long time, and maybe the initial move of data from on-prem to the cloud, that's going to take a long time. And the initial time you maybe get this cloud resource inside, behind your firewall, that may take a little bit of time. But once you've got all that kind of that baseline set up, then the ability to move really quickly and do prototypes is really great. And maybe not just prototypes, maybe it's a very specific one-off analysis. So let's say you've got a data scientist, he's got this model, and it's going to need just a ton of server resources in it. You don't want to stifle him, or you don't want to slow him down. You say, okay, great, Mr. Data Scientist, here's a gigantic server hosted up in the cloud somewhere. Run your analysis on this, and after a few days, we're just going to shut it down. So those are the kinds of ways that we see our customers moving to the cloud, above and beyond just costs. It's the ability to be agile and fast and do real quick prototyping. Any more questions?
I think you covered them all.
Okay, well, very good. Yeah, I think we're right at the end of our time, Jenna. I'll hand it back over to you.
Great. Thank you so much. I think that was really good, and I think you brought up some really good discussion points for those considering a move to the cloud. So thanks again to all of you for taking the time out of your day to join us as well, and I hope you enjoyed it. In closing, I do want to mention that I will be sending everyone a follow-up email, and it will contain a link to the recording in case you want to reference it later or share it with your colleagues. So please feel free to do so. All right, so that concludes our webinar today, and hopefully we'll see you next time. Thanks again, everybody. Have a great day.